All right, here we go. Section 1-7 today. So you have two quick warm-up questions. These were two of the questions that lots of kids got wrong on the test. So go ahead and take a second. Remember the difference when you have this big looking fraction, what your first step is, and when you have the little looking fraction. So go ahead and write them down, pause the video, and then you try to solve them first. All right, so the difference again between the big fraction and the little fraction. So the big fraction, my first step is to multiply to get rid of that big giant denominator. So this is all dividing by 10, so I'm going to times by 10, and my 10s will cancel out. If I times this side by 10, I have to times this side by 10, which will give me that x plus 5 on this side. And negative 3 times 10 is negative 30. Then I would subtract that 5, right, because it's adding 5. And a negative 30 minus 5, if you turn that minus sign into that plus and a negative, right, then we have a negative plus another negative, so I'd get my negative 35. My problem when I have a littler fraction, I first want to get rid of my adding and subtracting. So opposite of plusing 5, we're going to minus the 5 to both sides. Up here, I wrote it out left to right. So negative 3 minus 5 turns into plus a negative 5. Again, so I get negative 8. And the last thing I need to do is get rid of this divide by 10. So I multiply both sides by 10, and negative 8 times 10 is negative 80. Okay, so today we're going to learn about these things called functions. And at the end, you're going to be able to use function notation to write and solve some stuff. And you're going to use and test whether things are functions or not. So there's kind of two parts to today. All right. A function is a relationship between our inputs and our outputs. Okay, so remember you're pausing the video. So go ahead and pause the video. Give yourself some time to write all of this information down. An input, remember, is your x values, and your output, remember, are your y values. So a function is a special relationship between those x and those y values that we've been graphing and writing in tables from section 1-6. In a function, in order for something to be a function, there must be one output for each of the inputs. So only one thing can come out for each x value. So really, one of the easier ways that I think, this is the real definition for functions, is I like to say an easier definition is x can't repeat. Because if x repeats, I'm going to show you. So if you have a function, there's exactly one output for each input. So if I have an x value of 3 that goes with a y value of 4, that x value of 3 has one output right now. It has a 4. But if I also have a 3 in the x and then say as a 5, now if it's a 3 in for the x or the input, I have two different outputs for that same number 3 input. Again, I think an easier way is x can't repeat. So if I gave you these two ordered pairs and I said, are these two a function? You would say no, because the x value of 3 repeats. We're going to practice that a bunch in just a few minutes. So we're going to look at graphs, and we're going to look at tables, and we're going to look at mappings, and we're going to look at ordered pairs to test whether these things are functions. So this first one, the domain and the range and the mapping, is a function because each x value, negative 3 goes with 5, 0 goes with 3, 2 goes with 2, 4 goes with negative 1. There's no x value that's repeating. If we were to have something like this and say, well, also 0 could go to, that's not a very straight line, hold on. We could also say 0 also goes to 5, then it wouldn't be a function because 0 could go to two different things, which means that x value of 0 would be repeating. So right now, as it sits from the beginning, this is a function. This graph over here is actually a function. We're going to learn a shortcut when you have a graph. But if I said when the x value is 1, right, here's my x line, here's my y line. If my x is 1, it's graphed right here at only one y value. If x is 3, I'd go over to line of 3, I have one y value. And even if I go in the negatives, if I go to like negative 2 and I go up, I only have one y value. All the way over here, I go like negative 7 or 8, and I go down and I have one y value. So these are all functions. Okay, so really what we're going to do is we're going to talk about our functions. Remember, domains are your x values, ranges are your y values. We can talk about domains are my inputs, right? Ranges are my outputs. We're going to talk about a lot of that in our lesson today. Okay, so this is going to be part of your assignment today. It's going to give you either a mapping or a table or a graph or a list of ordered pairs, and you have to say whether it's a function or not, okay? So what we're going to do is we're just going to practice a couple. So if I give you this, one of the easiest ways I think is to take a mapping like this and list out your ordered pairs. So that first ordered pair would be the point -2, -2. The next one would be 0 goes with 4, and then I have 3 goes with 4, and then I have 4 goes with 6. So do any of my beginning, remember in our coordinates it goes the x and then the y, do I have any x values that ever repeat? Since I don't, this means it's a function. So determine if it's a function. Yes, it's a function. It is a function. And we know it is because x doesn't repeat. I'm going to go ahead and rewrite that so you can actually read it. Doesn't repeat. Sometimes the maps are the hardest ones to tell whether they're functions or not. That's why I like to list them out as the ordered pairs. And once I see all the ordered pairs and I see that I have all different x values, then I know it's a function. We don't care about the y values when we're testing functions. We could care less about what the y values. They could all be 4s, and that's fine, as long as we don't have any x values repeating. So here as a table, remember, go ahead and pause it, and then we'll check back in. So if you write these down, the domain, remember, is the x, and the range, remember, is the y. So if I list this first one as an ordered pair, I'd have the point 1, 4. The second one would be 3, 2. The next one would be 5, 4. And the last one would be 1, -4. So is this a function? No, because my x value of 1 repeats, because when x is equal to 1 repeats. Right? Most of the time in algebra, our tables are not written horizontally like this. Most of the time they're written vertically, but they could be written horizontally like this, and it's still, we have to test it. All right, last one is when you have a set of ordered pairs. So if I have an ordered pair set, usually we name sets and we put the little squiggly brackets on the outside. So I have a point 2, 1, and 3, -2, and 3, 1, and 2, -2. So is this a function? Really, I only need to look at my x values, right? I got an x value of 2, and an x value of 3, and an x value of 3, and an x value of 2. So actually on this one, I have 2 x values that repeat. So really, you can explain it in either one. You could say, no, it's not a function. Not a function because when x is equal to 2 repeats, and actually, or you could say x equal to 3 repeats. Okay, so that's when you have a mapping and a table and a list of ordered pairs. Then there's this other way that we're going to test functions when they're on a graph, and it's called the vertical line test. Okay, so the vertical line test says that if you were to draw every single vertical line that's possible, and if every single vertical line that you draw passes through no more than one point on the graph, then it's a function. Okay, so this one can get a little bit tricky, but if you follow with me and like really process through what I'm talking about, then it should be a really easy way to tell on a graph. Okay, so make sure you have that definition down. You've paused the video to catch back up, and we're going to go through 3 examples. So really, we're going to test, does this blue line make a function? So what you're going to do is you're going to, in theory, draw a million vertical lines. Now, could you really fit a million vertical lines on this piece of paper? Probably not, right? But you could, what they're saying is, draw a bunch of vertical lines and try to make them as vertical as possible, not like my crooked lines. So if you draw vertical lines, that one crosses only once. That one crosses only once. Every vertical line that you draw can only cross once. If you ever see a vertical line that crosses twice, then it's not a function. So since every vertical line crosses only once, or maybe it doesn't cross at all, which would be fine. Yes, this is a function, and we know because it's called passes the vertical line test. And if you want to call it the VLT, that's fine, vertical line test. So here's an example of one that's not a function. I can draw vertical lines out here, and it looks kind of good so far, right? It never crosses more than once because every vertical line can't go through more than one point. But as soon as I draw a vertical line over here, it goes through a point right here on the graph, and it goes through a point right there. So this one is not a function because it fails the vertical line test. So you have to be able to draw all the lines and make sure it passes that vertical line test. Okay, this last one's a little bit tricky. We're not going to get to any of these on the test, but I want to talk through it. So this open circle means don't include this point. Okay, so I draw vertical lines over here, and it looks good because each vertical line over here is only crossing once, only crossing once, only crossing once. I draw a line here, and at first it feels like it's crossing twice, but in reality, this open circle part here means don't include that. So it really does only cross once. And then all the ones over here, right, are only going to cross once. So this one, yes, is a function because it passes the vertical line test. Okay, so those are the first parts is our things functions. So the maps functions, the listed ordered pairs, the tables, and then now the graphs. And then the second part of today is this function notation stuff. Okay, so function notation can get kind of confusing if you're not careful. But we're going to skip this. If you get notes from me, skip this whole slide. So function notation looks like this. It's just a way to name an equation. And we're going to work a lot with equations this year, starting in chapter 3. So really, the rest of the year, we're going to call equations y equals. But function notation just starts with this. It's called f of x, and it doesn't mean f times x. When you're working on something, f of x. In this section only. When you see the f and the x pushed together, we're talking about functions. So what we're going to do is we're going to take these functions and we're going to work through them and solve some little mini equations. Okay? You could have a function that starts with g of x, and it would just be with a g in front. We'd call it g of x. And then you're going to have an equation like this, maybe minus 5. Okay? So you're going to get an equation like this. The f of x or the g of x does not mean take f times g. Now, it's just a fairly interesting way of writing an equation. So what we're going to do, again, this is a new way of writing, but if you follow with me, we should be good. So it's going to say either use this f of x equation, or we're going to use this g of x equation. So really what you have to pay attention to when you're doing these problems and on your assignment today, look to see, does it start with an f or does it start with a g? If it starts with the f, we're going to use the f equation. If it starts with the g, we're going to use this g equation. Okay? So we're going to start with the f equation first and do these two. Really, what all this means, if I say find what f of 2 is, you're going to take this 2, that's like the x, right? Here it is, the x. You're going to take this x and put it into the x, and we're going to solve it. All right, this equation means negative 4 times x plus 7. So we're going to do negative 4 times, we're going to plug in that 2 value plus 7. Then we're just going to solve it using order of operations. I'm going to multiply before I add. So negative 4 times 2 is negative 8. And negative 8 plus 7 gives me a negative 1. Right? So if I asked you to find f of negative 2, you would plug in a negative 2 up here. You would do negative 4 times negative 2 and then plus 7. Negative times a negative makes a positive 8, and a positive 8 plus 7 is equal to 15. So really this just means put whatever numbers inside this parenthesis in for the x in the equation. It's kind of like our expressions that we've been working with, but it's this funky way of writing them. Okay? Now what happens if I say find f of negative 3 plus 1? We're first just going to do this. We're going to do the f of negative 3. We're going to get to that answer, Then we're going to add 1. So I'm going to take this equation, I'm going to put the negative 3 into that x right there, right? So I'm going to do negative 4 times my negative 3 plus 7. I got to rewrite that whole equation out, right? It's negative 4 times whatever the x is plus the 7. Negative times a negative is a positive. Positive 12 plus 7 is 19. Then, okay, so we just solved the f of that negative 3, right? We got 19. Then the last thing we do is at the end, we just add 1 and get my final answer of 20. Okay, now what happens if I say do a g of negative 3 equation? Really all this means is, because it starts with g, we're going to go up here and use this g equation. Okay, I'm going to put this negative 3 into the x in the g equation. So it would look like this. 2 times my negative 3 minus 3, right? Because the g of x equation says do 2 times whatever x is minus 3. 2 times negative 3 is negative 6. And negative 6 minus 3, if I turn that into plus a negative 3, I would get my final answer of negative 9. Right? So this is just a fancy way of taking and saying, solve this if x is equal to whatever the number is inside the parentheses here, and then plug it in and solve your equation. It's just a fancy way of writing these equations. Don't let it trick you up. Okay, so what if I asked you to do this? Do g of 2 and then add it to f of 2. So we're going to first, oops, sorry guys. We're going to first do the g of 2, and then we're going to add on that f of 2. So f of negative 2, sorry. So we're going to do g of 2 first. So g means I need to go to the g. G of 2, I'm going to go 2 times 2, and then minus the 3, right? Because the whole equation says do 2 times whatever x is minus 3. 2 times 2 is 4, and 4 minus 3 is 1. And then I would add it to this stuff. And over here, I need to do the f of negative 2. So I need to go to my f equation over here and put the negative 2 into that x. So negative 4 times negative 2 plus 7, right? So we have to put it in the whole equation. Negative 4 times that negative 2 plus that 7. Negative times a negative makes a positive 8. And 8 plus 7 gives me 15. So then my final answer, if I add the two values together at the end, I get 16. Okay, last thing is if I gave you an equation, now this is new and you don't have this in your notes if you get notes from me, but if I give you an equation, I said, if g of x is equal to x squared minus 3x, and then I said, solve g of 4. You need to put this 4 into this x and this x when you're solving. So if your original equation on your assignment today, there's going to be a couple that have these two values, two x's, put them into both. So you would do 4 squared minus 3 times, put the 4 in there. 4 squared, remember, means 2 4s multiplied. 4 times 4 is 16. And then I'd have a negative 12 here, or minus 12. And 16 minus 12 gives me that final answer of 4. So if you're working on these and you get an equation or a function notation equation that has two x values, you plug that value right there into both of the x's when you're solving it. Okay? You should be good to go. Remember, you have a couple different things on your assignment today. One is, can you test these things if they're functions or not? Remember, you're looking for, does that x value repeat? And then the last one is basically doing expressions again in this fancy written way. So take whatever, make sure the idea is that you're watching which equation you should be plugging them into, the f equation or the g equation. I mean, it could be an h of x equation, right? These are just the two common ones, f and g. All right, you should be good to go. Good luck.